Okay, so we're going to be over the assignment for Geometry 3.2. So that's the thing we're going to be talking about and answering questions, and I'll just repeat the questions so people at home can hear it too. We got people that are going to be missing today and tomorrow. I'm trying to make sure I got that covered for them. But what I wanted to make sure of as you're going through, ask questions. I got some folks that are just floating through life and they're just kind of like, hey, doing just enough to get by. And here, that just leads to tons of confusion, especially this week. We've had 3 days, same words. Okay, have you noticed that? It's all about position when you have two lines crossed by a transversal. Okay, now when those lines are parallel, I have these really cool properties. Alternate interior, alternate exterior, and corresponding are all congruent, and same side interiors are supplementary. Okay, but when they're not parallel, I don't have that. And today we're learning that if I have the alternate interiors, the alternate exteriors, and corresponding congruent, or the same side interiors supplementary, I can say by the converse of the theorem that they're going to be parallel. Okay? So now I'm doing it again. I'm using those words again today. So if you are still floundering, it's like, what is he talking about? It's D-Day today. You gotta get it understood. You have to. Because if you're not, ouch. Okay? So here's the deal. I'm gonna just look over one here. I think I'm gonna look over one. You can actually see it. And I want to make sure that you guys understand what's happening here. And number one, they're asking, you're given 43, and in 43, I know that if this is 43, angle 2, angle 5, angle 6. The measure of angle 6 equals the measure of angle 5 equals the measure of angle 2 is equal to 43. Angle 2 is a vertical angle. Angle 5 is alternate interior to angle 2. And angle 6 is a vertical to angle 5. Or angle 6 to the 43 angle is alternate exterior angle. I don't care which one you thought about with that, but I need you to know that I'm using properties. It's not just like, well, Bloom said so. That's just because it looks like it. I mean, the looks like it, hey, that gives you a pretty good hint. Okay? But you have to have a justification with why you know stuff. Okay? Yeah, great, you have the answer. How did you find that? Oh, I just found it under a rock. It seemed like the right one. I didn't look under any other rocks. All right? So just keep that in mind. There's got to be a reason for what's happening. Now, in number 2, we're talking about angle 2, alternate interior angles. Angle 6, vertical angles theorem, and angle 4, corresponding angles, are all 148. Okay? And number 3, angle 4, corresponding angles, and angle 2, vertical angles. That's how I know. I'm telling you. Because how do you know that? How did it happen? And if it doesn't seem to make sense as I read it, hey, I'm willing to work it again. Number 4, angle 6 is vertical. Angle 9 is alternate interior angles. And angle 11 is corresponding angle. Angle 15, I got a corresponding angle to angle 11. Angle 13, vertical angle to angle 15. Angle 4, corresponding angle. And angle 2, vertical angle again. It's crazy what's going on, yeah. Yeah, let's look it over, because I've got people who are like, what? Because there's tons of stuff going on. But if I go here, these are parallel. This is parallel to this. So now I know here. I know that this is vertical. I know that that's vertical. Okay, are you okay with that side? Okay, I've exhausted the red. Okay, now I'm going to go up to blue. Because we start with that angle right here, and I'm looking at what, alternate interior. I got a vertical, okay. I got another alternate interior here with the red coming out this way. Okay, so I've got another red. I'm just going to use a green thing because I'm using this red here, and I've got alternate interior. And now I got a vertical, okay, as I'm going through. Does it make sense what I did? And I'm just stepping through where I know stuff, and based on the things I already knew, I use that other set of parallel lines. Okay? Does that help as I step through? Okay? Now, I'm okay with going over it again, too. But you got to know it's all about the properties provided. Okay, if I was going to put up a fence post, I was going to pour some concrete, put them in the yard, put a hole in, put a big old stick in that thing, and fill it with concrete. And then I was on a hill, I would want to make sure every post is parallel to every other one. Otherwise, my fence would look absolutely horrendous. Okay? It'll probably keep something out, but probably fall apart if I don't take care of having it square with something. Well, I'm using these properties as I go, okay, to help me pour that cement, to make sure everything's vertical, however I'm going to go about doing it, okay? And then when I snap my line to put in my bottom part of my fence and the top part and be able to zip in those boards, I'm doing the same thing, okay? So it's not just here, it's just where are you going to find the application for it, okay? So you got to keep in mind, these are basics. It's not, well, this is the be-all, end-all, how to use this. No, you're just learning how it works. And after that, the limit is your imagination. Okay, you got an app for that, right? An application, you're going to apply the stuff that you know. All right, now, in problem 5, I'm looking at angle 2 is 130 because of its corresponding angles, and angle 1 is 50 degrees because of the linear pair. 6, angle 1, 79 degrees, alternate exterior angle, and measure of angle 2 is 101, linear pair. Okay? Shoot.
Just take a step back. Number 5, what?
Angle 2 was the measure of angle 2, and number 5 is 130.
Yeah.
Corresponding angles.
Yeah.
Angle 1, because they're a linear pair with 130. You see that angle 1? We are talking about the fact that I subtract that from 180 and find out that it's 50.
Okay.
Okay? Yeah. Okay, we got it? All right. So 7. Just like we did in class yesterday, measure of angle 1 was 76, alternate interior angle, and measure of angle 2 was 61 because of same side interior angles. Remember, same side interiors add to 180. So 7, when I'm looking at 7, let's talk about that. When I'm looking at problem 7, 76, angle 1, the measure of angle 1 is 76. When I'm looking at problem 7, because these are on the same side, 119 plus the measure of angle 2 are supplementary. So they'll add to 180. So I subtract and I find out the measure of angle 2 is 61 degrees. Okay? Any other follow-ups with that? Great questions. 8. The measure of angle 2 is 122. Same side interior or vertical angles. Measure of angle 1 is 82 degrees, corresponding angles. Okay, questions there? Yeah, so let's talk about that. So if I go, this is my parallel line, right? This is 82, the measure of angle 1 corresponding. Measure of angle 1 equals 82 degrees because it's corresponding angles. Okay? Now, when I'm looking at this next one, I'm talking about 2 here, okay? And I'm looking at 58. 2, vertical angle there. Do you see that 2 is a vertical angle with the inside angle in that intersection? And now I know angle 2 and that 58 degree angle are same side interiors. So the measure of angle 2 plus 58 is 180. And now I've got the measure of angle 2 is equal to 122 because of same side interior angles. Okay? Not pulling any punches. I'm being very direct about the names. Make sure when you are working with these today, or even hopefully from now on, you actually say the right name to yourself internally. Okay? If you're one of those people that talk to yourself, great. I find that, you know, when you need the opinion of an expert, you should ask, right? So if you talk to yourself, that's what you're doing. But I also want you to know that you should use the vocabulary when you do that. It's another opportunity for you to learn the names and how they're related as you look at diagrams and find out what they're doing. Of course, I'm expecting it to be the correct names vocabulary. Okay, going on. In 9, Anna made a zip line for her tree house. To do this, she attached a pulley to a cable. Well, check out, these trees are parallel. They're telling us that them suckers are parallel. I got a zip line. Hey, look, they're same side interior. So I got 75 plus whatever the measure of angle 1 is equal to 180. Well, the measure of angle 1 must therefore be 105. So that's angle 1. Okay, so we're looking at this and we're talking about the fact that angle 1 is the same side interior, so I got 180 minus 75 is 105, and it's same side interior, so I answered both questions as I worked the problem. Okay, so they're same side interiors. Okay, now in 10, something that we did in notes, x is 52. Okay, so I got 52 and 128 for my angles. In 11, x is 18. Okay, so I got 60 apiece for my angles. Which one, 10 or 11? I can do both. Okay, so here's the deal. Let's talk about 10 and 11 as we go through. So on problem 10, keep in mind, I'm looking at this parallel line and that transversal. And now I've got to come up with the name of those two angles. Okay? And people are like, what do you mean? There's an angle pair right here. They're same side interiors. They're on the inside of the two parallel lines and on the same side as the transversal. So now I have 2x plus 24 plus x equal 180. Now I've got 3x plus 24 equal 180. Now I subtract and I get 156. Okay, and I got 3x. Well, 3 goes in 156 52 times. Okay, so x is equal to 52. Well, x was 52, and I got 52 times 2, which is 104, plus 24, and that's going to give me my 128. Excuse me, 52 should be 104 if I do this. Let me make sure that that's clear. So that's 104 plus 24 is going to give myself, for this angle right here, 128. Okay, so I got those nailed. Now, 11. These are the parallel lines. Now, the more junk I put in your way, the harder it is to see. If I stood in front of a student and say, okay, write this stuff down on the board, they'd be like, boom, what's your deal? And I keep moving every time they take. This is a kind of a fun thing. It's like basketball, right? If I just keep moving in their way. Well, if I keep putting crap in your way that you can't see really the basics, it makes it harder. Your brain starts thinking, oh, this has all got to be important. Well, it's not. Throw out the junk, okay? I'm just looking at just this one thing. I have an angle right there and an angle right here. These are corresponding angles. And in parallel lines, corresponding angles are congruent to each other. So now I've got 3x plus 6 is equal to 4x minus 12. All of a sudden, once I translate that from my diagram to my algebra, people are like, oh yeah, this is easy, Bloom. Okay? I get that over there. I got 3x plus 18. Bring that 3x over, and I get x is 18. Well, that's pretty styling. And now I'm looking at my answers once x is 18, and they're both 60 if I plug in. Okay? Are you doing all right with those? Sean, are you okay with that question? Yay, nay. Did it go okay? Okay, I just wanted to make sure before I slid on. And 12, I got x is equals 19.5. Freaked people out because they were like, they're supposed to be good numbers. 19.5 is a good number. It behaves really well. I've never had to sit it in the corner. Okay. 13, we got x is 29. And the value of my angles are y. The y angle is 110, and the 2x plus 12 angles 70, and the 3x plus 23 angles 110. So we got a couple things going on here. And as we go through, people are going to wonder about that. So shoot.
Yeah, how'd you get x is 29?
Yeah, how did I do that? I just make stuff up. That's all I do. Okay, you ready? Vertical angles. Are you okay with that? So now I've got same side interiors. So 2x plus 12, that's one angle, plus my other angle, 3x plus 23, is equal to 180. So I got 5x plus 35 is equal to 180. And I got 5x is equal to 145. So now I'm at the point of saying, well, hey, that's 29 at this point. And I'm able to pop that in there and pop that in there. Okay?
Do we actually just have to find the angles?
I just got to find the variables. And then I'm plugging them back in to make sure I'm doing it right. Find the values of the variables. But in this case, I need to plug it back in because I need to find y. Okay? So now, after I plug back in, I got 29 times 2 is 58 plus 12. So this is 70 up here. And since, I was doing this, I wanted to check to make sure I didn't have any fat fingeritis on my calculator or I made a mistake. Okay? So 29 times 3 plus 23. Okay? Now, that's going to come out to be 80, or 80. It's going to come out to be like 110 as I get that done. Okay, and you can check that with your calculator, plugging 29 times 3 plus 23. Okay? Now, those are going to be 180, and that's exactly what I thought it would be. And now, since I've got y and 110 are corresponding, I don't have to do much more work. So now y is 110 because they're corresponding angles. CA. Okay. Now my last thing I got going on here, when I do stuff like this, I've got people kind of watching along in that, and they're going, oh yeah, I didn't get that done, but I'm totally going to understand that later. Understand it now. Okay, I've got people who went through the assignments and it's kind of like, oh, I had a question on that and just didn't do it. It came back and nailed you on the test. I promised you in chapter 1. I promised you in chapter 2, and yet this promise is still consistent. I will not waste your time nor mine, more importantly mine, by doing something that isn't going to be tested. Ain't going to happen. Okay? If I present it in the class and you don't get it, ask a question about it. Pretend it's on the test. I always have people going up, can you help me with this? I'm like, no, I can't. It's a test. I can help you every day. Okay? But I can't help you on test day. I actually had a student go home complaining to the parents, he wouldn't help me. And they like shot off a horrible email to me. And I was like, it was a test. I wasn't going to help them. Oh, I'm really sorry about that email. It's like, thanks, have a good day. Okay? Folks, ain't going to help you on a test. Know the material. You also have a note card you should be preparing for. So keep that in mind as we're going through angle 1 and angle 2. It ain't given, is it? It's not even in the given little thing that we're doing here. Okay? So I've got given, and I've got a given. Where's 1 and 2? Where do you see it? They're vertical angles. Do you see them? Okay, they're vertical angles. So by vertical angle theorem, I know they're congruent. Okay, those are straight up. Here's the deal. As we're getting going, I got 2 and 3 are supplementary. Okay, 2 or 3 are supplementary. How do you know? Same side interior angles. We're looking at, they tell us that C and D are parallel, and we got this going on. 2 and 3 are same side interiors. Okay, now I've got some folks going, oh, that's how we use this stuff? Mm-hmm. Now, I know A and B are parallel. Okay, they told me. So I've got A is parallel to B, all right? And now I've got this transversal again, but I got 4 and 3. How do I know 4 and 3 are related? What type of angles are they? They're on alternate, yep. So we're talking about alternate, I'm just going to put this in, alternate interior angles. Okay, boy, that doesn't look like much of an eye, does it? So alternate interior angles. Let's see if I can, hey, good, that looks better. Now, this last one might be new, okay? Some people see it maybe as a substitution, but you're really substituting 2 congruent things in a situation where they are supplementary, okay? So when I'm doing this, you want to make sure of the fact that you're thinking about congruent supplements, okay? So as we're going through, congruent supplements theorem. And congruent supplements theorems reads, 2 angles that are congruent to the same angle, or supplementary to the same angle, or congruent angles are supplementary as well. Well, these 2 angles are congruent. These 2 angles are congruent. And do you see that where I see 3, and you see that where I see 2, I can use this as congruent supplements because they are congruent to the same angle. And that's how I can say this. Okay. I know it's kind of a substitution, but I cannot use substitution in congruence. I can, however, use it in equality, and that's what congruent supplements does. It breaks it down as an equality thing so I can get it done. Any other follow-ups there? Okay. I try to be as clear about these as possible. If you still have questions, I'm here tonight. I've got hall duty this evening. It's Wednesday, so I'll be down in the Commons. If you have questions, come on down. I'm just standing there making sure no one's behaving like a fool and hurting themselves. So just make sure that you come down, we can talk. Okay. Now, next thing, as you're handing up your stuff, I want you to open up your notes to page 5. As you're handing up your stuff, I want you to open up your notes to page 5. after you hand up your stuff, open up your notes to page 5. At the top of the page, on page 5, I would like you to answer this question. I'm asking you to write the converse of the statement. And the original statement I'm asking you to work with, if it is cold out, then I wear wool socks. Okay? If it is cold out, then I wear wool socks. I want you to write the converse of that statement. Thank you, sir. You're writing the converse. Keep in mind the converse, I even give you the rules for converse. The converse asks you to switch those two statements. If I wear wool socks, then it is cold out. Okay? As opposed to doing house chores by, dusting the floor, shuffling along, getting the corners where nobody walks. Okay, so if I've got wool socks on, it is cold out. That's the converse. And people are like, what is the deal? Now, if you look at the board I've got over here, it's the same board that I had yesterday, except I have included the word converses. Okay, we did corresponding angles, which is CA. We did alternate interior angles, AIA. We did alternate exterior angles, AEA. And we did same side interior angles, SSIA, yesterday. Today, we're worried about the converse version of those theorems. Okay, and what's the difference? Yesterday, we were given lines that were parallel that were cut by a transversal, where your properties with these angles come true. Today, we're noticing the properties, and they're a symptom of the lines being parallel. Okay, and that's why it's the converse as we go through. Now, what I'd like you to do at this time is recognize the difference. Today we're looking at the converse of the corresponding angles postulate, CCA, converse, corresponding angles. If two lines in a transversal form corresponding angles that are congruent, and those are corresponding angles, angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8, then the lines are parallel. Okay? And I'm hoping that you're starting to notice, because I'm using converses today, that my 3 missing blanks on all 4 of these are then the lines are parallel, or at least the lines are parallel. Okay? So keep in mind that as we're going through. That's the theme. The converse of alternate interior angles doesn't have a diagram. Please put one down there. It's the same diagram that's above and below. Just sketch it in there. Okay? Make sure you get those angles that are working on that too. Okay, as we're going through this, when we're doing this, I want to make sure you recognize converses as we do this. Okay? They're used to prove lines parallel and nothing else. Okay? Use to prove lines parallel and nothing else. On this next one, same idea as we step these through. Okay? Make sure you're comfortable with what's happening. we are using these properties today to prove lines are parallel. You're going to see these properties come out. You're going to see alternate interior angles are congruent. You're going to see alternate exterior angles are congruent. You're going to see corresponding angles are congruent. You can see same side interior angles are supplementary. And because of that, you're going to be able to use the converses to say that the lines that transversal cuts across that allows those angles to form are parallel, okay? So keep that in mind as we're working through the reasons for why we know stuff. So here it is. Make the change here in notes, please. Make that change. Make that change in this next piece. I've got those blue arcs. Those tick arcs should have been in your notes. I apologize for that, but I neglected to write that in because the program that I was using to write them in did not work really well. And I couldn't get the right picture for myself. So here it is. Put in those tick arcs, and now let's answer the question. First thing, identify the names of the angles. What's the names? Are they alternate interior, corresponding, same side, same alternate exterior? Which one of the four is it? Corresponding. You see them? Because they're corresponding angles. Okay? These are corresponding angles. Corresponding angles are in the same relative position. Okay? Because they're corresponding angles, I will be able to say that A is parallel to B because of the converse of corresponding angles. Okay, CA, converse of corresponding angles. Does it make sense? Okay, I'm told something, and I don't know that they're parallel. Yesterday, I gave you that they're parallel. We had markings. We said in the directions, hey, these lines are parallel cut by a transversal. Find the measures. Okay, find the variable. Today, you're like, okay, you're given this situation. You're given these properties. What do you know? And you should be able to pull out from the names of the angles and markings and everything and what's provided, that they are parallel. And this next one, what do you know why in 65? Name the name of the two angles relationship. Is it alternate interior? Are they corresponding? Are they alternate exterior? Are they same side? Same sides. So we're able to say, well, heck, those are same sides, so I know that y plus 65 are 180. Now I solve for y, and I know that's 115. So my next thing to do here, now state the theorem or postulate that proves A is parallel to B. Okay, if y is 115, then these two lines, A and B, are going to be parallel by converse of the same side interior angles. Okay, that's how I know it. And converse of same side interior angles. And people are always after this. Like, well, why is it different? Because yesterday you were told the lines were parallel, cut by a transversal. They make these angles. Today you're told these properties exist. What do you know about the lines? Can you prove that they're parallel? If so, which of the converse theorems are you using? So, in 3, as I step up, in number 3, if I'm looking at 120 and x, what type of angles are the greens? Corresponding. So I have that x must be, if x is 120, if x is 120, I know A must be parallel to B because of the converse of corresponding angles. Okay? Now, the next thing, I'm going to put those to the side for a second. What if I'm talking about these two values? What's y got to be if they're going to be parallel? 120, right? So y's got to be 120. And if that's 120, I'm thinking, well, hey, what's the name of y in 120? Those angles. Alternate x, fantastic. So today it's converse because I'm saying, hey, excuse me, I want to put that down on the other line. I'm saying that A is parallel to B, my two lines that I'm working with, A and B. A is parallel to B because of the converse of alternate exterior angles. Now, I've got some people going, oh, okay, that's fine, but what about W and Z? Well, W and Z are related to X and Y because they're a linear pair with them, right? Do you see it? So if x is 120, what's z? Because x is 120, 120 plus z must be equal to 180, so z's got to be 60, and I probably should have a different color for this. Okay, I'm really showing these as I'm going kind of slow. I want to make sure people recognize that that's what I'm doing. But not only is z 60, but what do I know about w? So I'm done with those things. Because I'm talking about, hey, they're z and w are vertical angles with each other, so they should be the same, but they are linear pairs with x and y. Now we're going to do less each time. So in the next one, in 4, what do I know about x right now, looking at the diagram? How do you know it's 50? I got people. Okay, careful, vertical and linear pair. Which one? Is it vertical or is it linear pair? Vertical. Okay, so vertical angles, keep in mind, are made by opposite rays, two sets of opposite rays, so x is 50. Okay, so now if x is 50, how can I find y? What type of relationship is the 50 and the z? Y. The 50 and the z, excuse me.
Oh, 50 and Z.
Same side interiors. Okay, so by same side interior, I know 50 plus z is 180. So now I know z is 130. And because z is 130, I can now say with absolute confidence that A and B are parallel because of the converse of same side interior angles. Notice we found the name, and now we use the converse of that name to show the lines are parallel. Okay? Now, as an offshoot of finding z, what do I know about angle y? Because it's vertical with z. Okay, it is also 130, so I can actually say that that is the same as well. Because y is a vertical angle with z. Questions about these? Is it making sense? You guys are throwing them out there nice. Do 5. 5 is just 1. It's pretty straight up. And so is 6. But 6 is kind of got a wrinkle on it. So do 5. Do 5. See how you're doing with 5. Identify the name. Think about the property. And identify the name again. Do them together because every time you say the name and the property, you'll remember them better. Okay? The name, the property. Identify the name, identify the property. Okay, I got my names. Okay, alternate interiors, right? My property, they're congruent, therefore equal. So 95 must equal 2x minus 5. I add and I find out that x is 50. All right, as I'm stepping through. I'm able to pop that in. 2 times 50 minus 5 is 95, so I'm real confident that I found it because I said that they are equal, and they are. Now, I know that when x is 50, A must therefore be parallel to B because of the converse of alternate interior angles. And that's how I'm doing this. Okay? Your turn on 6. Go ahead and get it done. After you do that one, lean left, right, check out with your row partner, see what they got and what their reason for why A and B are parallel. Now, keep in mind, for ease of this, I have used every line I named A, B, and T. Okay? On the assignment, those will change because I want to get used to writing different notations. So we're going to cover those answers, the first 2 questions of the assignment together, just to make sure you get it. Okay, remember, why is A and B parallel? Let's give you a hint for something though. What did I just use? Did I use one of the four, or did I use something else we already knew? Do you see vertical angles? And I have people go, why? Why did you do that? Because I needed to get to a relationship to make my next step. 19 going in makes these same side interior angles. Same side interiors are supplementary. So if I have same side interior angles coming up to a certain value, I can then say the lines are parallel by the converse of same side interior angles. So I've got 19 and 17, that's 36x equal 180. Are you okay with 5? So I got x is 5. So I pop that back in and find my two values. Okay? This should be 95. This should be 85. Okay? Comes out to be 180. When x is 5, I now have A parallel to B because of the converse of same side interior angles. Okay? Because of the converse of same side interiors. I have to be able to come up with the relationship, and then because of the converse of the relationship, I get it. Do 7 and 8. Remember, that vertical angle trick is helpful. You don't have to use it on either one of these two. Okay. Name the angles, set up the relationship, solve for the variable, and then use the converse to state that's how you know the angles are going to be, the lines will be parallel. The converse allows you to have that reason. Did you get that 55 was equal to 3w minus 2? Because those are alternate exterior angles. Okay? I identified the angles as alternate exteriors. That allows me to know my relationship that I set up. Those angles are supposed to be congruent, therefore equal. I solve, and I get w is 19. Okay? Now, when w is 19, this should be 55. Okay? Now, after I do that, I got to know that I used alternate exterior angles. By the converse of alternate exterior angles, I know A is parallel to B. Okay? So I've got it. So, and people always go, how do you know which one? I have to name the angles I'm working with. Okay? Or have some sort of relationship with those that I can make. In 8, when I look at them, do you see same side interiors? Okay? So I've got same side interiors going on. I get after them. Okay? Are you okay with x is 30? Okay? Now, after we do that, keep in mind, when we're working with this, I can plop it back in. 30 times x, or 30 times 2 is 60 plus the 9, I got 69 plus 111. That best be 180 for me to make this work, and it is. So it worked out. So now by the converse of same side interior angles, I can say that A and B are parallel when x is 30. Okay? For what value will x or y or z of the variable will make the two lines parallel? By what theorem? Okay? Those are the things I'm answering today. You got 2 left, 9 and 10. So it's converse of corresponding angles. You guys just have two. They're going to get the other ones. Okay, don't worry about that. Bobby, you guys got yours in the other row to your left. Okay. Okay. Hopefully this is making sense. Okay, again, checking this out. Look, it's 2x, vertical angles. I have alternate interiors then. If I chose, I could have gone x plus 2 up here, or x plus 21, and it had been alternate exterior. Or, did you see corresponding? Okay, so I could have gone corresponding. But either way I do it, all three of those require me to know that I set them equal to each other. Okay, so really if I go straight up, I've got A is parallel to B, all right, by the converse of corresponding angles. And then my last one, what? They don't have to be. They could have been alternate interior. They could have been alternate exterior, converses. So it just depends how you decided to set it up and approach the problem. Okay? So now my last one, I've got converse to alternate exteriors. Do you see them? Alternate exteriors set equal. And we're golden, hopefully. Okay? Now remember, as we're stepping through, the difference between the regular theorem and the converse. You only use the converse when you're proving lines are parallel. And you'll be asked. So read the directions. Notice the diagrams of what's going on. You should not pull out a converse if you're not asked to prove lines parallel. Okay? Thanks for your time today, folks.